multiplying polynomials. Okay, so just very quick, I do just want to review that we do call polynomials by name. So if they have degree numbers, like if they have a degree 1, we call it, let me just go back up, excuse me. If we have a degree 1, a degree 0, we call it a constant. Let me see if I can. Okay, so we have a degree 0, we call it a constant. We have a degree 1, we call it linear. Degree 2, we call it quadratic. Degree 3, cubic. And anything that has a degree 4 or higher, we just call it a 4th degree polynomial, 5th degree polynomials, 6th degree polynomial, 7th degree polynomial, and so on. Okay, so I just want to review that so that you guys keep, how we call it. Now, sometimes in our book, they do say something like this. So if we have something that's like, I don't know, 2x, we'll just call it a monomial, meaning 1. If we have something like, I don't know, 2x squared plus, I don't know, add another 3x, then we call it a binomial, right? Because we have 2 terms, right? And it's a word by. Then if we have like 3 terms, like 3x to the 4th plus 3x plus 4, then we can call that a trinomial. Trinomial. And if we have anything bigger than that, I haven't seen the book call it anything else. Yeah, I think after that we just call it again a polynomial. Okay. So just keep in mind, again, sometimes the book keeps referring to these and they'll say, oh, add this and this, or add this and this. And so you just want to make sure that in your mind you know that a monomial has 1 term, binomial has 2 terms, right? And a trinomial has 3 terms. Okay. All right. So now let's get to the fun part. So now let's get to multiplying. Okay, so review. So I'm going to go ahead and review with you guys. Review your exponents, right? So if anything to the power of 0 will be 1. If I have x, so a variable to the power of 0 is 1. X to the power of 1 is just x. X squared just means that you're multiplying, right, 2 x's, which gives you x to the power of, right? You add the exponents, right? So I'll put that later. So x to the power of 3, x times x, right? And so let me do this now. All right. So 1 plus 1, when you multiply variables, you add the exponents, right? So 1 plus 1 will give you 2, right? So if I give you something like x to the power of 3, again, you're literally just adding the exponents, which gives you x to the power of 3. So when you multiply, that's what I want you to know. When you multiply, when you multiply variables, you're actually adding their exponents. Likewise, if I give you x to the power of 4, that means you just have 1x, 2x's, 3x's, 4x's, and again, you add the exponents. Okay, so that's just review of when you multiply variables, what do you get? Okay, now let's get to the fun part. So I have a little list of numbers that I want to do with you guys. So I'm going to start with 2 here in our book. You can also follow along and open up your book if you want. Completely up to you. The book does it a way they like want you to use like squares. I didn't learn it like that. You could totally do it like that, but I honestly think it's sometimes easier to just multiply by what you guys already are used to. So I'll say example number one. So multiply. I have x plus 5 times x plus 8. So I'm at 5 minutes already. I want to make sure I do this with enough time here. So again, this is back in the day we used to call it FOIL method, right? So x times x will give you, right, when you multiply two x's, what do you guys get, guys? X squared. So we get x squared. X times 8 will give you 8x. 5 times x will give you 5x. And then 5 times 8 will give you 40, right? So we combine the like terms, right? So the like terms are right here, right? So 8x plus 5x gives you a total of 13x. And, right, you just drop down your x squared plus 13x plus 40, right? So this is your answer when you multiplied those two quantities, okay? So I guess I can write steps. You could say FOIL, right? And then step number 2, combine like terms. Combine like terms. Okay? All right. So that's example number 1. Now let's go ahead and do example number 2. So let's see. Example number 2 gives us... Give me a second, guys. Let me pull it up. Let's see. So now let's add a variable. So let's go ahead and do, I'll do this one with blue. So let's do 2x plus 4 times x minus 5. So you do the same exact thing, guys, okay? So let's do it. So 2x times x gives you 2x. X times x gives you x squared, right? 2x times negative 5 gives you negative 10x. 4 times x gives you 4x, right? And then 4 times negative 5 gives you negative 20. And then you combine your like terms, which gives you, right, 2x squared, right? Negative 10x plus 4x gives you negative what, guys? What does it give you? Negative 6x, right? So this is what we get. So that's multiplying polynomials. We're multiplying two polynomials. And in essence, right, this, again, just to do like review or something, this is a binomial, right? And this is another binomial because we have one term, two terms, right? So two terms. And this is also a binomial because we have two terms. So we're multiplying two binomials, right? And we get a polynomial of degree. What's the highest degree here, guys? 2, right? So we get a polynomial of degree 2. Okay. So when we multiply, and essentially these are also polynomials, right? So when we multiply polynomials, right, we still get polynomials. So in our book, this is what they call the closure property under multiplication. Okay, so just if you guys are reading the book, just make sure that you guys understand that the closure property, all it really means is that when you multiply polynomials, you're going to get polynomials, right? So that's what we call closed in mathematics. Okay, so that's example 2. I just wanted to point that out there. All right, number 3. Let's see if I have enough time. How many minutes? I'm at 9 minutes and 47 seconds. Okay, so let's do a harder one. So let me do number 4. So let me see if I can do 4. Okay, so number 4, here it is. X squared. I believe this is example 4 in your book too. So just so you guys know. So plus 2x minus 1 times 3x plus 4. Now you guys can multiply using sort of like an area box or an area model. You guys can do whatever you guys want. This just to me seems a lot simpler. Okay, so let's do it. It's kind of like a really big FOIL, but you just multiply in every single term. Okay, and we're gonna do it step by step. So I'm gonna do this pink. So with this term, I'm gonna do it with green. So let's do x squared times 3x gives us 3x, right? And then remember, guys, this has a little exponent of 1. So remember I said that we have to make sure we go ahead and add the exponents when we multiply variables, right? So 2 plus 1 will give you x to the power of 3. Okay, we're going to do it again. So now we're going to go ahead and do x squared times 4. So that one just gives us 4x squared because we don't have an x squared right here, right? We just have technically x is 0, but we don't care about it. All right, now I'm going to do the next one with blue. Okay, so now you took care of this first term. Now you got to make sure you go to this one. Okay, so I'm going to do this one now. I'm going to do, okay, 2x times 3x, right? Okay, well, that gives me 3 times 2, that gives me 6, right? 6. And then x times x, right? Both have a little exponent of 1, gives you x to the power of 2. And then I'm going to do the next one, okay? Then I'm going to do 2x times 4. Right? So 2x times 4 will give me plus 8x, right? Because again, this has an x and this one doesn't have an x. Okay? All right. Now that takes care of the 2x. Now I'm going to go ahead and do, let's see, I think red would be good for this one. Now I'm going to go ahead and take care of the 1. All right. All right, so I'm going to do -1. So -1 times 3x gives me just -3x. And then -1 times 4 gives me -4. Okay? So then after this, you just combine like terms. So now I'm going to use, let me see if I can use some type of highlighter here. I'll use this one. I'm excited to try this. So now you want to just combine like terms. So if you notice here, this and this have the same exponent, right? So you want to combine those. And so let's go ahead and do it. So if I go ahead and do those, I know that 4x plus 6x will give me 10x squared. Cool, I like this color. I'm going to do this one, okay? And I'm going to combine these like terms right here. Okay. All right, so you guys, if we put these together, right, 8x minus 3x should give me 5x, right? And that wasn't a very good color, but all right. And then you just drop down your, let's see, just see if I can do it in white. All right, you drop down your -4 because there's no other like terms, and you drop down your, right, your 3x squared. So 3x squared. Really, so your polynomial, when you multiply it together, you do it, take it step by step. You do first x squared, then you do 2x, then -1 into every single term of the other binomial, and you get this beautiful looking thing, and this is your polynomial, right? Again, when we multiply polynomials, we get polynomials, so it's closed. And let me double check my answer. 3x squared plus 10x squared plus 5x minus 4. Yep, that's correct. So now we're at 14 minutes. That's pretty much